All right, guys. So we started working with Laplace transforms, and in particular, we started taking a look at functional transforms as opposed to what we call operational transforms. We did go through one example previously. I want to go through some more examples. So this is a continuation of functional transforms, and this is example number 2. Now, it's very easy to argue that amongst the most important types of functions that you will see in differential equations in the time domain are exponentials. So in this particular case, the problem itself, let me do the problem statement, example is, suppose that I'm given f of t equal to e to the minus, and I think the textbook uses a as a constant t, like this, where a is a constant, then find the Laplace transform of f of t. Again, we're going to go back to the definition. So here, the Laplace transform of f of t, by definition, is the integral from 0 to infinity of e to the minus st times f of t dt. And all I have to do in order to compute this, well, is I have to take this, I need to plug it into there, and then I can actually perform the integral, right? So here, doing exactly that. So if I take the Laplace transform of e to the at, what I'm literally doing is I'm performing the integral from 0 to infinity of e to the minus st times e to the minus at dt, like this. And by the properties of exponents, one of the things that I can do is I can actually combine both of these under one single exponential. And on top of that, since both this has a minus sign and a t in common with that, I can also, in the same single step, I can factor all of that out. So this is the same thing as the integral from 0 to infinity of e to the minus s plus a times t dt, like so. And this integral right here is easy to perform as well. This integral is minus 1 over s plus a e to the minus s plus a times t. And I'm evaluating in the limit as t approaches infinity and as t approaches 0 as well. Now, notice that in that top limit, again, remember that what we're doing is we're actually replacing this t. The fact that this exponential has a minus sign here, right, means that as t gets bigger and bigger and bigger, that minus sign essentially guarantees that that exponential is tending towards 0. On top of that, this other part is essentially a multiplicative factor that is not affected by the limit whatsoever. So one of the things that we can definitely say here is that this is minus 1 over s plus a. And in that limit, as t approaches infinity, that first term goes to 0. And if I plug in t is equal to 0 into there, what I have is minus e to the minus s plus a times 0, like so. And that's very easy to evaluate as well. It doesn't matter what s plus a happens to be, as long as it's an integer, well, times 0, that's actually going to end up being 1. So this was 0, like that. And what we're left with is minus 1 over s plus a times 0 minus 1, or 1 over s plus a. Now, once again, keep in mind that there are going to be some restrictions placed on the values of s that this can actually take on, just to make sure that all of these functions are actually well behaved. But as a summary or a result, one of the things that we can definitely say, being kind of sloppy with the restrictions, is that the Laplace transform of an exponential of the form e to the minus at is 1 over s plus a, like this. So this is the function of s in the Laplace domain. And again, we will take a look at some more interesting examples here in a second.